All right, hopefully 8.3, lesson 8.3 has been kind of making a little bit of sense to you about special triangles. Now we're going to look at ratios in right triangles and an exploration with that. And so we're going to do another exploration type video here. Make sure you are on this page, 8.4 Ratios of Right Triangles Exploration. So this is what we're going to do to start with. You're going to kind of investigate what happens with some right triangles. Now, it says to draw three similar right triangles with a 50-degree angle, labeling one triangle ABC, where angle A is the right angle and B is the 50-degree angle. Label a second triangle, so on and so forth. Because I'm such a nice guy, I have gone ahead and done all that for you. So you should have one of these half sheets of paper. If not, pause the video real quick to make sure everybody has one of these half sheets of paper with these three triangles on it. Okay? This way we all kind of get the same answers and it is a little bit easier. So I've measured these out. We have three different right triangles, each with a 50-degree angle. These would all be similar then by angle-angle similarity. And so they will have proportional side lengths. And so these ratios we find in a minute should work out. So what I want you to do is complete this table. And I'm going to help you get started, then pause the video so you get enough time to do this on your own. What I want you to do is to measure these lengths of each triangle. You'll notice for triangle ABC, you're going to measure AC and BC. BC is the hypotenuse. Okay? And AC is the side that is opposite the 50-degree angle. So we're looking at the opposite side compared to the hypotenuse each time. Okay? So I want you to measure those with a ruler. Everyone should have a ruler. If not, there are extras to be borrowed. And it would be best in this case to use centimeters. I use centimeters to draw these, so we want to measure in centimeters. Like if I measure AB here, that should be 2 centimeters. Okay, so be careful and make sure you're measuring these correctly. But AB is 2 centimeters. Okay? Now, that's not one you have to measure, so that's okay. Excuse me. I want you to measure AC and BC. Make sure you're measuring to the nearest millimeter. Okay, so be careful about that. Okay, take those measurements and record them there for triangle ABC. Take the same side measurements for triangles MNP and XYZ. Record all that, and then I want you to write the ratios and try and simplify them to see if they're the same. Okay, and so I'm actually not going to have you do a whole lot more of this in class. This is kind of what you have to do as homework. So I want you to take the measurements and fill out this table. You can do this at home. Make sure you have a ruler. If you don't have a ruler with you and need to take one and borrow it, please make sure you bring them back to me. I don't have a lot of these to just give out to you guys. I wish I did, but I don't. So I want you to make sure you take those measurements in centimeters and record everything in this chart. Okay, that's why I've given you the half page. If you want to glue or tape this into your notes, you're welcome to. You don't have to once you're done with the chart. And then I want you to make a conjecture about the ratios of these legs that are opposite the angle marked 50 degrees compared to the hypotenuse of the triangles. Okay, I want you to make a conjecture about that. That means make some kind of conclusive statement. All right? All right, and then I want you to fill out the back here. You should be able to do this on your own. Okay, I've given you these different triangles, and then I've given you an angle to use as a reference angle. Okay, so in these special triangles here, you have two 45-45-90s triangles and two 30-60-90 triangles, and I've given you reference angles to use in each one. That means that's the angle you're going to determine opposite leg or adjacent leg to. Okay, so on this first one, the opposite leg of a 45-degree angle, since there are two, you just get to pick one. The opposite leg is 1. The hypotenuse is radical 2. We don't want to leave that in that form. We want to rationalize this. You want to multiply top and bottom by root 2. Okay, so you get 1 times root 2, that's just root 2. Root 2 times root 2 is 2. So that's that ratio. So I want you to keep working through these and fill out this part to talk about in class on Friday. That is your homework.